Okay, so what we're going to prove now, or what we're going to construct and prove, is the construction of a regular octagon. So again, we start off by drawing a circle of any radius. You open up your compass to any length and you draw that circle. Now what you do is you're going to construct a square. So in order to construct the square, you draw a diameter, any diameter. And once you do that, you construct the perpendicular bisector of this diameter. So you should know how to do that from construction of the square. So I'm going to construct the perpendicular bisector quite simply just by drawing, if I can, just by, again, imagine I construct this perfectly, but this isn't going to be perfect. But here is the perpendicular bisector of that line. And let's just move that. Now, so I have here that this will be a square. If I connect these points, would be a square. But what you do is then again now is you construct the angle bisector of this angle. And I'm just going to refresh you for each one of these right angles, right? This is this line, right? This green line that I'm drawing now or going over again is, remember, the perpendicular bisector. So these are all right angles. Right? And then you construct the angle bisector of this right angle right here. So the angle bisector, you open up your compass to some length and you go to here and you just draw that arc. And then you go from here and you do the same arc. And then what you do is you draw the line from the center to that point. And then this will be the angle bisector. Now you do that for each one of these four angles. And I argue after you've done that, what you have is where each of these lines meets the circle, you have your regular octagon. So let's label these points A, B, C, D, E, F, G, H. And what I do is I connect all these points and I have a regular octagon. So I'm going to do that real quick. And let's prove that this is indeed a regular octagon. And if I want to prove it's a regular octagon, I want to prove all the sides are congruent and all the angles, all the interior angles are congruent. So in order to do that, the first thing I'm going to prove is that these triangles, these 8 triangles, are all congruent. Now, in order to do that, I'm going to say, well, let's see. So the first thing I got is, let's see. So I could say that this are all congruent. That's obvious because they're all radii. So let's write that. So proof. All, let's call the center point O to each one are congruent. All radii are congruent. So then that means that all of those lines that I ticked out, all those segments are congruent. Then I'm going to state that we should see that this angle is the same as this one by definition of bisector. And we should also see that it's 45 degrees. And we should see that then each one of these are 45 degrees. And then I'm going to say that the triangles are congruent. So I'm going to say that, all angles are congruent by definition of angle bisector and construction, because I constructed the angle bisector. And then once I have that, all these angles are congruent because again, they're all 45. And you can see that by side angle side, all the triangles are congruent. So all 8 triangles, 1, 2, 3, 4, 5, 6, 7, 8, all 8 triangles are congruent. Therefore, all your triangles are congruent, and by CPCTC, we have that all the sides are congruent. So this is the same as this, is the same as this, is the same as this, the same as this, same as this, same as this, same as this, right? So I have AB is the same as BC, CD, DE, EF, FG, GH, HA are all congruent. Right, are all congruent. And that shows that we have that all the sides are congruent. Now we need to show that all the angles are congruent. Well, these triangles, this angle is the same thing as this angle, so let's call it angle 1 and angle 2. Just make it easy. Angle 1 is congruent to angle 2 by isosceles triangle theorem. Right, this side is the same as this side, so then this angle must be the same as this angle. And then once I have that these two angles are the same, then this one is the same as this one, and by CPCTC, all of these angles are actually the same. And since all of these angles are the same, this angle must be the same as this one, and all of the angles are the same as well. And this shows that A, B, C, D, E, F, G, H is a regular octagon. Thank you.